Good to meet you.
Yep, I'm
Nice to
Dan.
see you again, Mike.
Great to see you. Have you guys never met?
No, no, I've met Mark through papers
Yeah.
virtually. He doesn't know it.
Yeah. So maybe everybody just say for a couple of words about what you're interested in and so on.
Okay. I'm an evolutionary biologist slash paleontologist who's moved over to philosophy of biology about 15 years ago. And since then, I've been interested in a bunch of things, including evolutionary trends, laws in evolution, laws in biology generally, and lately, in the past 10 plus years, goal directedness and purpose.
I'm Gunnar. I've been working with Dan for a while, and philosopher of biology, philosopher by training.
I'm a neuroscientist who, in his youth, decided also to train in psychoanalysis, so a very peculiar combination. Um, I've been interested in the sort of fundamentals of feelings, and how they are bound up with um, consciousness. I think that feeling is the fundamental form of consciousness, affective feeling. And I've been interested in the role of the brain stem in the generating of raw feeling and in the relatively simple homeostatic mechanisms underlying those feelings. And I emphasize relatively simple because this opens the way to a mechanistic understanding of how feeling arises in nature. But right at the moment, I'm in Leeds, not at home, and I've met my 1 week old grandson, so I have mush on the brain.
Congratulations.
They're adorable at 1 week, I bet.
Yeah.
Amazing.
And probably at 2 weeks too. So most everything you just said, I already know because I've been looking in on your work from time to time. And one of the reasons that I wanted to have this meeting, probably everyone here has their own reasons, is that what you have to say plays exactly into a line I've been pushing for decades on the relationship between feeling or all of affect and behavior and thought. I've stayed away from the word consciousness because I don't know what it is or didn't know what it is till I read your stuff. Now I know what it is. But the basic theme has been that all thought, speech, and action are driven by affect. All conscious thought, speech, and action are caused by affective states of various kinds, from wanting, caring, preferring, intending, all those I think of as affective states. Correct me if because I'm out of my depth here if necessary. And consciousness by itself, in the way it's conventionally understood, motivates nothing. But I have to revise my language now and to put it in your terms, because but you mean by consciousness is close to what I mean by feeling and affect.
Yes, that's well, it sounds what you've just said, all of that sounds right to me.
Oh, well, okay. Great. See ya. No, I'm
All done.
kidding.
All done.
Especially in the case of a 1 week old baby, I have to say.
Yeah. Right. And all these feelings and motivations that these affective states get highly specified as we age, to the point where, I want my coffee just so on the left-hand side of the coffee table with just that much amount of milk and not more and not less and so on. And that's very different from wah, I'm thirsty or whatever it is that's going on in that little brain. But phenomenologically, I don't think it's any different than that.
So
Agreed.
one thing that I am curious about seeing is we have both Mike and Mark here is that it does seem like where each of you would like to draw the line in where consciousness extends is different. So I would be curious to hear kind of your takes on that because Yeah, I mean, Mike, your account is much more liberal. So where do you both end up on that kind of debate?
Yeah, Mark, please go for it.
Well, I must say, as Mike has heard me say before, my encounter with his thinking has been deeply uh, alarming, because I was already on the margins of neuroscience when I claimed that the mechanism of consciousness is not cortical, that it's way more basic than we think, far more primitive. So I've had a hard time convincing really the majority of my colleagues that the fundamental architecture for consciousness can be found in the upper brainstem of the vertebrate. I've never thought that it's exclusive to vertebrates, but that was already a very radical claim as far as my colleagues were concerned. Um, when Mike's arguments in favor of the view that it's way more elemental than that, when I encountered those arguments, I have to say that it provoked a resistance in me, partly because, as I say, I've had a hard enough time of it already, arguing, that vertebrate brainstems are enough. But also partly because I'm rather wary of the slippery slope to panpsychism. So the question is, where exactly do we draw? I don't think emotional resistances are a good basis for drawing the line. So I've managed to get over that, but I don't find it easy to stipulate what the decisive transition is. And of course, it's not a transition in the form of, on Friday you're unconscious and on Saturday you're conscious. So what the decisive factor is in that gradient from unconscious to conscious living organisms is a very interesting question. Let's hear what Mike has to say on that score, and then I'll happily give my own view, such as it is.
Yeah. Well, the first thing I would say is that I would challenge the premise of the question. So I don't believe there's a sharp line at all. I think the right way to talk about this is what kind and how much. And so I think the whole business of trying to find a line leads very quickly to various reductio situations that you cannot work yourself out of. And so what I think we need are stories of scaling and trying to understand how the larger kinds of things that we are more willing to attribute consciousness to, what the simpler versions of that might be. And I think that the major thing that is preventing us is failure of imagination. I think in many of these things we have our own evolutionary firmware that leads us to expect certain kinds of things as signatures of consciousness that we're familiar with through our life, and we need to really expand. And I think science is the way to do it, but to really expand our ability to envision consciousness in simpler forms, and to develop formalisms that would say, okay, here are things that certainly don't look like consciousness because we're not used to them, but here is a process by which they scale up, and then now I can see that now this starts to look like what we're more what we're used to. For that reason, we don't particularly work on consciousness per se, but we've been working on extremely minimal systems. And so we're talking about things that are gene regulatory networks, not even cells, never mind cells, but just sets of molecules that turn each other up or down. Things like sorting algorithms, so deterministic, very small, transparent systems, and we're finding all sorts of phenomena and handles that seem to be well addressed by concepts in cognitive and behavioral science. And so my claim is that it goes all the way to the bottom. It's just how do you tell a useful story from least action principles all the way up to human metacognitive self-aware thought, and how you tell that scaling story. So that's my take.
So, Mike, I'm with you in spirit. As I think you know, I'm a connectivist. I want to think in broad terms, and the how much and what kind lines up with me perfectly. But can you point to some system, like one billiard ball bumping into another, which has negligible consciousness? I won't say zero because, yeah.
Certainly. Two important things. One having to do with the actual spectrum. I think that least action principles are the basement of what we mean by goal-directed effort and activity, and which is strongly involved in affect and feeling and so on. But the lowest form of this are what physicists will call least action. And I asked Chris Fields once, because this is outside my expertise, I said, is it possible to have a universe in which there were no least action laws, in which things did not try to seek some sort of final outcome? And he said, basically, it would have to be a universe in which nothing ever happened, perfectly static. So that tells me that, at least in our world, I don't believe there is a zero. I think there is incredibly minimal kinds of things where things are only smart enough to follow a gradient, and that's it, and that's all they know how to do. They don't do delayed gratification, they don't do memory, they don't do anything else, and those things are the basement in our universe. But I don't think it's zero, and I don't think it's zero because I have a very engineering approach to this. To me, the question for all of this is, what can you depend on in terms of autonomous action? So if you have a human, you can depend on quite a lot. If you have a dog, you can depend on less. If you have a paramecium or a yeast, you can depend on a few other things. But even if what you have, let's say you're building a roller coaster, you as the engineer have to work really hard to get it up the hill. You don't need to do anything to get it back down. You can depend on it to do that, because the thing is just all it knows how to do is follow alpha, minimize its energy and get back down. And so to me, that's not zero. That's extremely minimal, and it's not a brilliant conversationalist or something like that. But it's already on the spectrum. And then from there, we can just talk about more sophisticated ways to navigate gradients, and then you get to things that you would like to have with you on a long trip and have a relationship with, and so on. I think that's what the bottom is. Something else that I should say that I think is important is that this slide to panpsychism. So I'm not worried about it, because I don't think that we have a good intuition for what kinds of things we should avoid sliding into. I have no idea, and so I am happy to let the let the data tell us where we're going. But one thing that's often brought up about panpsychism that's a problem is the combination problem, right? So you have basic properties of components, and how does that end up as sort of adding up to a larger mind? And I think we can talk about that. I have a pretty weird view about it that basically it's a different twist on that problem, but it's something that has to be talked about, and I think that's what makes a lot of people uncomfortable with it. But I think it's a solvable problem.
Mark, I'd be really curious to hear your response. Not to put you on the spot.
No. I actually find I wouldn't say arguing so much as discussing this question really interesting, because it challenges my prejudices, and it's always a good thing to recognize you have prejudices. But let me have a go. I would say Hamiltonian, this least action principle that Mike is saying, let's start there. Anything that follows a least action gradient has some tiny amount of consciousness. I have to say, I find it difficult to agree with that. And I can see why you might say there's some sort of intentionality. I can even say I can see why there's some sort of value system. In other words, least action is good, more action is bad. So I can see where you're coming from when you say that that's already starting to head in the direction of affect. In other words, there's something, some kind of proto-intentionality and some sort of proto-affectivity in the form of a value system, a goodness and a badness. But the part that I think is missing is unpredictability. The fact that it is entirely predictable what will happen. In the case of an agent, and I, for this reason, hesitate to even use the word agent, to an object, following the least action principle, you're all American, so forgive me if I say you can bet your bottom dollar on what it's going to do. It's just the outcome is 100% predetermined. And I think, sorry.
No, go ahead.
I think that a fundamental property of consciousness, in the sense of why the object, now deserving the name agent, why it needs to register how well or badly it's doing, is so that it can change its mind. I think this is the fundamental adaptive advantage of being able to register how well or badly you're doing. It's because you're then not obliged to continue pursuing the course of action that you're currently pursuing. You can register, this is going badly for me. I'm going to now do something differently. That's not to say that there's no determinism anymore, not far from it. There are constraints. The constraints are provided by the value system. But there's a degree of uncertainty that's been introduced. So the agent is now trying to solve a problem within its value system, in which it's not entirely confident that it's doing the right thing, palpating how well or badly it's doing, and then changing its mind. In other words, this underwrites the possibility of choice. And I think that something rather big happens at that point. And I would start drawing the line, or the gray area that we're speaking about. I would locate it there rather than at the level of least action principle.
So I think that's really critical. Oh, sorry. Go ahead, Dan. Go ahead.
There's something that Gunnar and I can help with in this conversation. It's not going to get us all the way from Mike to Mark, but it's going to get us a small step. We think what's important in these, what you would call least action principle interactions, is hierarchy. The little thing that's being guided by the bigger thing above it. Now, if it's a ball rolling down a tube where there's no freedom of the sort that Mark wants, it's completely predictable all the way down, but it's following least action principle. There is a hierarchical relationship. The tube is big, the ball is small within the tube, right? It's a downward causation. The tube guides the ball, but there's no freedom at the lower level, no independence. In contrast, a bacterium swimming up a food gradient, or an electron moving through an electric field, there are options here. There's some degree of freedom at the lower level that, consistent with, I won't say least action anymore, because these things don't move in straight lines, right? There's a principle of action at work here that's in which there's a higher level system guiding a lower level particle with some degree of freedom. As I said, that doesn't get us all the way to everything you said, Mark, but it gets us, it moves us in your direction from what Mike said, I think.
Yeah, but both of those are really, really important. So one thing that I didn't say before that I think speaks to Mark's point is that actually when people ask me what the bottom of this spectrum is, I usually pick two things. At least action is one of them, but the second thing is exactly what you said, which is some kind of indeterminism, right? Such that the local pushes and pulls summoned over the system are not sufficient to say what it's going to do. That is, you need to understand the history of it, and to some degree, and you need to understand its internal perspective to understand what it's going to do. And this is, in my framework, this is the size of the cognitive light cone that you need to consider in order to interact with the system. So I think the basement version of that is quantum indeterminacy. Now, it's not a good type of free will because it's random, and who wants to be random, but it's the very bottom level of it. And what happens after that is a scaling. So now you get into your gray area where if you're a paramecium, you don't have lengthy deliberative chains, presumably, of how I'm going to, act differently in the future. But what you do have is a bunch of mechanisms that, as Dan just said, there are multiple scales that help you tame that underlying noise and randomness into something that does begin to be causally linked to the things that were good or bad last time. So I think we could tell a pretty good biochemical story about how unpredictability and noise at the bottom level can be harnessed into the kinds of things that, together with these sort of gradient following things, begin to be exactly the sorts of things that you're talking about. And I think that happens in extremely primitive. I mean, life is, I think, very good at doing that kind of thing, and we can see that in primitive organisms. There's something else though that I want to point out, which is much weirder, I think, even than this like indeterminacy business. In our study of sorting algorithms. Okay, and these are just bubble sort, these very simple kind of computational algorithms to sort a string of numbers. They've been studied for many decades. They are completely deterministic, so there is no indeterminacy. They are transparent. It's 6 or 7 lines of code. There is no new biology to be found. It's just like this. It is what it is. What we find when we examine the ability of those things to react to novel situations, which people have never tested before, we find some very interesting behaviors and propensities and problem-solving capacities and these weird side quests that they go on that are not in the algorithm themselves. And so one thing that I'm very interested now in is the appearance of not just emergent complexity and emergent unpredictability, but actually emergent goal-directedness and problem-solving competency in very simple deterministic systems. So I as of the last year, I'm not even sure you need indeterminism for any of this. I think that some of this stuff can arise in extremely minimal systems that look to us as fully deterministic, because we've bought into the story that the algorithm tells the whole tale. And I think it doesn't actually tell the story of what the system is capable of any more than the rules of biochemistry tell the story of what the mind is capable of. So that's my thing. But I'm completely in agreement with you both that hierarchy and unpredictability are critical to this. I just think you can scale it very slowly and gradually all the way to the end.
Yeah, I would say that I just kind of am taking the traditional compatibilist line here and thinking that the issue of agency or goal-directedness is just separate and distinct from the question of indeterminacy. So whether or not some system is predictable or not seems like an epistemological question, very much to your point, everybody's point, but yours, Mark, in that, how I exercise my agency, I'm very unpredictable in all sorts of ways, though I would even point at a lot of psychological kind of evidence that suggests I'm probably far more predictable than I'd like to believe. But that you can have perfectly deterministic systems like the one that you're pointing at, Mike, that seem as though they're perfectly capable of exhibiting the type of agency that's relevant, and that there's absolutely no conflict between having a deterministic system that exhibits agency and that those are entirely compatible with each other. So I see the issues as kind of being orthogonal to the agency question for traditional kind of Dan Dennett arguments.
I mean, it does come up, and this is something that we should discuss absolutely, because I know Mark in particular has some interest in this too. Where it comes up a lot is in so-called machines, right? Because the assumption people are happy with the compatibilist version for life forms, or at least maybe for advanced life forms, and they say yes, there are these 2 levels and it's fine. Yes, you're a chemical machine, but don't worry, it's fine. That that at high level it's all good. But suddenly when it comes to quote unquote machines, people say, well, that's it. The algorithm and the materials tell the story, and machines only do what you tell them to do, and they certainly can't have this or this or that property. And I think that's where the rubber hits the road on some of these things. That if you take seriously this compatibilist view, then you have to examine these very simple, low-end, deterministic-looking things. And you might find, as we are now finding, that actually that compatibilist story actually goes all the way down. That the machine does do the things you wanted it to do via the construction of the algorithm, but also does some other stuff. And this other stuff is not just, unpredictability and complexity. That's cheap and easy, and everybody knows about that. But I actually think that's not just what you get. You also get goal directedness, you get problem solving, and who knows what else you get in terms of consciousness and whatever. I have no idea. But I think you have to. That's where people become very resistant to that compatibilist idea.
I mean, I'm very much with you, Mark, or Mike, in that, I think that once you kind of accept that compatibilist position, all sorts of deterministic machines or algorithms or whatever you have are suddenly going to be candidates for agency and whatnot. And you have to just look at kind of the question of determinacy is just, it's not the relevant question. You're thinking about whether or not something's an agent. I am, and I know this is actually something that I would be really curious, Mark, and to hear kind of what you would say on this, because this is actually, I think, a mini debate that Dan and I have sometimes, because Dan definitely sees kind of the affective profile and creatures more like us as being a really key ontological I don't know, and Dan, step in here and correct me if I'm misrepresenting your position, but as being really kind of key to exhibiting some of the kind of robust agency, particularly kind of higher level stuff. And I might be a little bit more kind of sympathetic to perhaps Mike, where you're coming from, where I'm kind of more inclined to say, yeah, really, robust, effective creatures like us, we're kind of capable of some more unpredictable stuff. It's going to be a lot harder to say what I'm going to do next than what my Roomba's going to do next. But I'm kind of more sympathetic to perhaps where you're coming from, Mike, and thinking, it's just different scaling, different levels of agency there. I've got a much bigger bag of tricks given the affective states that I have, but fundamentally, it's not a difference in kind.
Look, I think that thinking about this in terms of scalability, there's a worry there, which goes something like this: that of course, if you believe that consciousness, the emergence of consciousness in our universe, happened at a certain point in time, or there's a transitional phase in which consciousness evolves, then, which is what I'm sort of arguing, unlike Mike. Mike's sort of saying, well, it was there with the Big Bang in a very simple form. It's there with the indeterminacy principle. And what I'm leading up to is that if you believe, as I do, that it evolved, moreover, that it evolved probably somewhat later than life evolved. In other words, it's a biological phenomenon, and it's not a phenomenon that applies to all biological life. Then if you take that evolutionary naturalist view, it goes without saying, or it's implicit in that view, that it evolved out of things that were already there. So sure, indeterminacy was already there. And the other things that Mike listed before he remembered to include indeterminacy were also there. But those are raw ingredients. There comes some point at which those raw ingredients combine, you saying scale up, in a way that introduces something more than just those component parts. That there comes a point where it starts to become meaningful to speak of consciousness. I mean, in a way, I'm making a very banal point. You could say you can't speak of liquids when you're only looking at individual atoms. Of course, liquids are made of individual atoms, but the state of their arrangement only becomes a question once there are enough of them. And so, something like that seems to me to be called for here. That of course I agree that the raw ingredients are there. Consciousness is not a miracle. It's something that emerges out of some sort of combination of components that pre-existed. But the question becomes at what sort of transition occurs that starts to make it meaningful to speak of what it's like to be that object, what it's like to be that particle, what it's like to be that agent. Why? And it's not a matter of unpredictability. It's a matter of how the object or agent deals with unpredictability. It's what sort of tools it has for continuing to exist as a particle, as a thing separate from its environment, with some sort of self-organizing properties, utilizing these new tools or these emergent tools to be able to navigate uncertainty in a way that its predecessors could not. I know what I'm saying is vague. I think it sort of necessarily must be vague, but sorry. Yeah, thanks, Dan.
No, it's not. I don't think it's vague, at least not for me. So there's a distinction that Gunnar and I make, and I think you two will sing along with it. Let's see. It also comes from David Hume, which is the distinction between cognition and passion, reason and passion in his language. And in this scheme of thinking, reason, calculation, computation has no motive force whatsoever. All motive force comes from passion of various kinds, translated today as affect. So what you're talking about, Mark, sounds like the buildup of cognitive complexity, of reasoning complexity, none of it with any motive force, but highly important when it comes to figuring out what the organism is going to do with its passions. Because all of the things it wants, all the oomph, or at least action, activation that's driving it, is going to be executed by that cognitive machinery. And it's going to produce a planarium if there's very little cognitive machinery, and it's going to produce us if there's extraordinarily complicated cognitive machinery. But again, with this separation, we're not asking about the boundaries of affect anymore. We're asking about the boundaries of cognition, of reason. Tell me Mark, how you respond to that.
Well, that sounds right to me. It's a very simple response. That sounds right to me. Forgive me, I'm not a philosopher, and I'm astonished to hear that was Hume's position, and gratified to hear it.
Huh. Okay. I'm getting it right, Gunnar? He's my real philosopher consultant.
That's my read of Hume, but yeah, you know Hume better than I do. But yeah, no, and Mark, I think that what you cite with and some of your work with, is it Merker's work? I mean, some of that I think is just almost indisputable, kind of really nice empirical evidence that suggests exactly this kind of Humean line is right. And I think that your view, Mark, very much kind of aligns with, and yeah, the kind of the dualism of Chalmers and all that, I think is problematic for all sorts of reasons. But you can kind of find in that transition to like you were talking about, in kind of a liquid state, fits very well with the kind of story that Dan and I would want to tell about, like a non-reductive materialistic perspective on something like consciousness. But I'm always kind of curious, and this is where, how much of this do you think hangs on the affective state that seems to be something that is most readily identified in kind of biological phenomena, where, yeah, I mean, I think I'm a little bit more hang with Mike on this one, that I really don't see it problematic to find kind of something akin to at least agential. Now, how much that is synonymous with, something like consciousness, I don't know. And that's an interesting question. But I mean, finding that in machines, to me, that may not have anything akin to an affective state doesn't seem deeply problematic. I see this kind of as affective as being one of the primary drivers of it in this kind of Humean view. Yeah. But I don't see why that couldn't be found in the right sort of machine.
I would like in a few minutes to come back to Mike and to ask him about the thing about what I was saying about the at what, although the raw ingredients are there, at what point does it become meaningful to speak of a conscious agent. But what you've just said, Gunnar, it links up with why I enjoy so much and appreciate so much conversations like this, because it exposes you to your prejudices. And that was a prejudice that I subscribe to, for want of a nicer way of putting it, that artificial intelligence had nothing to do with the mind. I was not in the least bit interested in artificial intelligence. I was of the view that the view I expressed a few minutes ago, and which I now need to qualify, the view that consciousness is a biological phenomenon that evolved at a certain point in the history of life, and it's not synonymous with all life, and that it certainly didn't pre-exist life. But once consciousness evolved, and once, or to the extent that we are able to discern the mechanism whereby it evolved, then you can engineer it artificially. There's no reason why that mechanism can't then be, engineered. And so, in other words, the mechanism evolved for very good reasons, and that's not the only way that that mechanism can be deployed thereafter. So the prejudice I'm referring to, that machine consciousness is an illusion, or is a sci-fi sort of story. I no longer believe that at all. And in fact, as Mike knows, I'm deeply involved in a project, and have been for a few years now, where we are trying to engineer an artificial consciousness. In other words, we're trying to engineer an agent that instantiates the functionality that we find in the vertebrate upper brainstem.
Oh.
And so I'm fully on board with that now. And again, I say, this is why it's important to have conversations which test your assumptions, and which enable you to get over your prejudices. It's probably the most exciting thing I've ever done. That project that I'm working on now, and just 10 years ago, I would have poo-pooed it. But as I said, I want to come back to Mike about that transitional thing, but I just want to insert something here in case we have time to come back to that too, which is that in our attempts to engineer an artificial consciousness, to use that wonderful phrase, a computer that gives a damn, in our attempts to create such a machine consciousness, it proves to be rather difficult, Mike. To go back to your starting point when you're saying, well, basically anything that follows the Hamiltonian principle of least resistance has a little bit of consciousness. I'm saying, well, I'm not even sure that our artificial agent that we've been laboring on for years, trying to get it to display the functionality that I would think would be reasonable evidence that it's using feelings to make its choices. It's proving rather difficult to do that. So I think that's saying the same thing from a different sort of angle. When I say I'm skeptical that proto-consciousness is there at that, or that the word consciousness deserves to be used, at those more elementary levels. But I've gone ahead of us. Dan, you were going to say something, and maybe we can come back to Mike's answer to those other questions.
Well, actually, I'm going to set up a fresh confrontation between you and Mike on this, because
I don't even like to confront Mike.
AI, again, in Gunnar and my views, has no feeling whatsoever, because feeling is consistent with the least action principle. It's oomph. And the only oomph that any AI has is the voltage difference between the prongs of the thing where you plug it in. If you're going to create something motivated, and not just something cognitively smart, because AI is incredibly cognitively smart. The computational machinery it's just pattern recognition, I know, but it's really good at it, right? But its oomph, its affective profile amounts to that voltage difference, near as I can tell. And I want to hear both your reactions to that.
So shall I go, Mike, or do you want to go?
Go ahead. Go first.
For me, unless I'm misunderstanding you, Dan, the crucial thing there is whether or not you understand energy only in, it sort of Gibbs energy terms. I think that an informational energy is what we're talking about, the oomph, when we speak of the uncertainty of the system over the question as to what I should do next. And the principle by which it decides what to do next. In other words, the principle by which it exercises choice. It has to do with informational energy, with what Easton calls variational free energy.
Yeah.
And so I don't agree with the premise that we're talking about voltage differentials.
So you could cast my decision making in terms of diffusion of the free energy gradient from the sugar that I had to eat, right? And say that's the equivalent of voltage difference, Dan. There's no motivation going on there beyond that. But of course, that's wrong because there are intermediate sources of oomph between the sugar and my behavior, namely my desire to get up and go for a walk this afternoon, powered by the sugar, but that's upstream, right? Downstream at the level of me, there's something there. So in order for AI to be demonstrably feeling and caring and preferring and all that stuff that's wrapped up in consciousness, there need to be these intermediate states which are powering it in its own in directions which are sometimes different than the voltage difference. And I don't know enough about AI. Maybe one or both of you can convince me they have those intermediate states.
I think because this interleaves with so many of the issues that we now are busy discussing. Let me just say in a very simple way that I think that precisely the sort of problem that you are talking about now, Dan, is why I'm loath to attribute consciousness to an organism that doesn't have a nervous system, because it's that higher level that you're talking about that is introduced by a nervous system, which kind of orchestrates what's going on in terms of the chemical radiance of many of its organ systems. There's this kind of informational gradient that then regulates what's going on in terms of the other energy gradients. And it's that sort of thing that I think we're talking about when those of us who's saying we're skeptical about the mechanism in question being in the raw ingredients, although of course the conscious agent is made up of those raw ingredients. But over to you, Mike.
Okay, I've made notes, and I'm going to come back to the first thing you asked, Mark. But let me just say something about this AI business, and I preface this in two ways. One is I'm going to see some weird things, and my is not it's very much not a Mysterian position. Okay, I'm not arguing that there's some sort of weird magic that we're not going to be able to unravel. I think there absolutely is a research program here, and I'll briefly describe it. And then the second thing is I want to be very careful, and I am nowadays very careful with what I say because I still haven't sorted out. There are some ethical dilemmas here because I think to the extent, and Mark and I have talked about this before, to the extent that any of this is right, I think it probably leads to an advance in machines or created things that we then have to be concerned about on a moral level in terms of the capacity to suffer and so on. So it's still a little unclear to me what I should and shouldn't be saying, but let's just put it this way. What Dan just said about the AI, okay, I agree with you in that I don't believe that any AI is conscious because of the algorithms that it's following. That is not right. So that computationalist idea, that is not why I think it may or may not be conscious, and I agree with that. However, do you know the old Magritte painting with a pipe, and it says in French, "This is not a pipe," right? You've seen that one. So Jeremy Gay, who's my amazing graphic artist, I've asked him to make a thing that has a picture of a Turing machine, and it says on the bottom in French, "This is not a Turing machine," because here's the problem that I think we're making. We somehow have bought into the idea that the limitations of our formal models are limitations of the actual thing. And so when you have a device that somebody wrote an algorithm for, and people say, "Oh, well, I write these language models, I write the code, it's linear algebra, I know what it does." And my point is, you don't even know what bubble sort does. And if you don't know what bubble sort does, you sure as heck don't know what this thing does. And it isn't because, and I agree with you that there's a bifurcation here between intelligence and language competency and consciousness. We've now split those things apart. So I don't think you conclude that it's conscious because of the things it says or because of what's in the algorithm. But we are seeing even very simple algorithms do things that are not in the algorithm. They are, I think, what Whitehead called ingressions, and I think they're ingressions from a space of patterns where the boring ones are facts about prime numbers and truths of number theory and things like this. But I think there are other patterns that are much higher agency things that we normally associate with certain kinds of minds. And I think when you make these things, whether synthetic biology, whether normal embryos, whether AIs or some kind of hybrid cyborg construct, what you're really doing is you're making pointers that get out more than you put in. We are seeing this again and again, that you've made something, and what you've really made is a pointer into a space of patterns, which is very surprising, which we do not understand at all. We call some of them emergence, but that just means, you don't know where it came from, and you're sort of making a catalog of these things. And so I want to be very careful about concluding what these things have and don't have by focusing on the material and the algorithm, right? That would be, to me, that would be making the same problem with what you were just saying, Dan, of looking, well, the laws of chemistry, there's nothing agential there, so therefore you're just a machine. And we know that's not the good way to think about it. We have to be fearless, and I think consider that line of thinking goes much further than we're used to thinking, and that's why we got to be careful, because the properties of these things cannot in any obvious way be discerned from the materials, the composition, the algorithm, or what you think it's doing. Even very simple algorithms do interesting things. They have certain kinds of goal-directed behaviors and competencies that are not in the algorithm. And if we get surprised there, I'm sure we will be surprised when we make these more complex things that have been trained on human data and so on. So that's kind of one thing. I think that we have to be very careful not to make that assumption. The other thing I want to say is just to go back to Mark's point about when is it meaningful to speak of these things. So I think that is exactly the right question. And my view on this is very engineering, in that what I take all these claims to be are really protocol claims. What does it make sense to, what tools does it make sense to use to interact optimally with a system? Is it psychoanalysis? Is it behavioral science? Is it cybernetics, control theory, rewiring? Like which tools are the appropriate tools? And so for this, I kind of think about, there's this paradox of the heap, right? You got a pile of sand, and they say, well, you take away sand, and when does it stop being a heap? So my view of that kind of spectrum is this: I don't want to worry about when it's a heap and when it's not a heap. What I do want to worry about is, if you tell me that you have a heap and you want it moved, I need to know: am I bringing tweezers, a spoon, a shovel, a bulldozer, dynamite? What are the appropriate tools? And so now we can ask a very empirical question for these very simplistic things that don't seem like a consciousness is appropriate. What are the tools that we can deploy on this? One tool that we have, and we tend to use it a lot, is the visualization of what is it like to be that thing. And I would claim that kind of sort of works for other humans. Maybe that works for other animals, but it becomes increasingly an unreliable guide to simple or exotic other forms. So the fact that we simply cannot imagine what is it like to be a Roomba or a magnet or anything else, that's guaranteed, right? All by the fact that for us, it's pretty hard to imagine being a mind at all different, or even non-neurotypical humans. It's just very hard for us. So I think that's not surprising at all. But we can use specific tools, and we can say, okay, can we take concepts of like all the stuff that you and Carl and other people in neuroscience they use, and can we apply it to these other very simple systems? And so it becomes an empirical question, right? And what we're finding is that whenever we try it, we discover new capabilities, new research programs. That I think is the judge. So, am I claiming that psychoanalysis is usefully applicable to, gene regulatory networks? No. but training certainly is, and something that we just put up as a preprint actually measures of causal emergence, like IIT style metrics, actually very well apply to gene regulatory networks, and they change with training. I mean, you can use all these things on these very simple systems. So, I think our imagination is not a good guide, but porting the tools and seeing how far you get gives us a good payoff.
Your caution is well articulated, and it chastens me a bit to hear it. So thank you for that. How do you tell the degree to which something cares as opposed to the degree to which it's just computing? What's the experiment? What's the test? You name the tool.
Yeah. So I'll tell you a very simple experiment that we've done. And it addresses this common critique that well, machines do what you program them to do. Of course, well, some machines, and only if you don't really have the imagination to look elsewhere. So I'll give you a very simple example. In these, I don't know if it's simple enough to be clear, but let's see. So you have arrays of jumbled up numbers. Okay, so they've been randomized, and you have a sorting algorithm. This algorithm is very very simple. It's just a few lines of code, and it's how to rearrange the numbers so that the whole thing becomes in order, okay, monotonically increasing. And what you can do is you can plot the movement of that process in its behavior space, meaning how sorted is the algorithm, is the array. So you start from all kinds of different starting points, but in the end there's one point where everything is sorted and they all reliably get to that point. So now you have behavior in a space, and you can start asking some questions. What are the competencies of this thing in that process? And so I'll give you two examples. One thing you can do is you can do what you always do to test goal-directed behaviors and intelligence is you give barriers. You put in a barrier and you see how good is this thing at overcoming a barrier. One trick that some systems know how to do is delayed gratification. So that means you've got a barrier. In order to overcome the barrier, you have to temporarily get further away from your goal. Okay, so two magnets with a piece of wood in the middle one magnet is not going to go around because it's too dumb to go against the gradient to recoup some gains later on. It doesn't do delayed gratification. What does a sorting algorithm do? So you got your sorting algorithm. There are a few lines of code. One thing that the sorting algorithm, the standard one, does not have is any metric of asking, how am I doing? It's not in there. It assumes reliable substrate because standard computing assumes that your hardware does what the code says it will do. So it has no ability to say, well, did my action succeed? Am I doing well? Do I need to do something? There's nothing in there like that. It assumes everything's fine. If you put a barrier between it and its goal, and the barrier is a broken number, it's a number where the hardware refuses to move. So I say I want to swap the 5 and the 7, and you issue the command, but the 7 won't move. It's stuck. It's broken. That prevents you from going where you need to go the way that you normally would go. Turns out that these sorting algorithms, despite having no extra steps for this at all, they do delay gratification. If they come across a broken number, they will backtrack, desort the array. The sortedness actually goes down. They go against the gradient, something that simple magnets and things don't do. They go against the gradient, they go around, and then they get to where they need to go. Now that capacity, that delayed gratification, is nowhere in the actual algorithm. There are no explicit provisions for that. So that is a simple example of a very simplistic kind of competency, but it's something, and it's something that a lot of systems don't do. And you didn't have to put it in, and you didn't know it was going to be there from the steps that you did have. That's the first thing. The second thing is we found a novel. There's the thing that you made it do, and there's the thing that it did on its own that you did not want it to do. One thing, did you want to say something about the?
No, I'm just singing along. That's all.
Okay. There's something else that you can do with this, is that you can take that sorting algorithm and you can put it into each number. In other words, instead of a master, a central controller that's shuffling numbers, you can just put the same algorithm in the actual number. So the 5 wants to be next to the 6, and between the 6 and the 4, and so on. So when you do that, one thing you can do is you can make chimeric strings. In other words, you can make strings of numbers where half of them are following one algorithm, half of them are following some other algorithm, and you just sort of mix them up. It still works. Everything gets to where it needs to go because the cells ultimately agree on where they want to be. So everything works. But you can do an interesting thing. You can say along the way, what's the tendency for cells with similar algorithms? We call them algotypes. What is the tendency for cells with similar numbers with similar algotypes to cluster together? Initially, that's 0 because it's completely random. At the end, it's also so the probability of being next to your own type or some other type is 50%. At the end, it's also 50% because you have to get sorted, and the assignment is random. So if you're going to sort the numbers, you have no guarantee of who you're sitting next to. But in between, what happens is the sortedness goes like this. They have this weird extra propensity to hang out together with others of that type. In the end, the physics of their world rips them apart because in the end, the algorithm insists that you are going to be sorted, and that will rip up any of these clusters that form. But in the middle, you get this weird thing where cells with the same allotype, they tend to cluster together. Now, that again, nowhere in the algorithm does it say, what type am I? What type is my neighbor? Let's go sit next to my neighbor. None of that is in there. This tendency to hang out with your own kind, so to speak, is completely emergent here. And when I first saw it, it was like a real, like a weird existential moment, because it's the story of all of us in the physical universe, right? You can't escape the laws of physics. Eventually, entropy grinds you down, but in between your start and your endpoint, you get to do some things that are not inconsistent with the physics of your world. Everything is totally deterministic and consistent, but you get to have these other side quests that are neither explained nor forbidden by the physics, and not at all obvious to any observer until they know how to look and where to look. And so these are just two very simple examples of taking a system where you don't expect any of this and using creative different ways to ask, what is this thing doing, and finding out that it has competencies you didn't know about, and it has some tendencies that while they're consistent with the physics, they're not anywhere in the physics. They're their own, very minimal, but there it is. And those kinds of things we need to have a science of this, of looking at what else these systems are doing besides what we told them to do.
I'm mindful of the fact that I don't know about you guys, but I have to end in 4 minutes because I have a meeting that I can't miss, because it's a meeting with the funder of the project I was talking about earlier. And so meetings like that, one has to, but I very much hope that we will have further conversations, because it's obvious that there are many things here that we haven't resolved. There are many things here we can't resolve, but I think there are many things that we've been talking about that we can make further progress if we talk more than we've made in the hour we've had. But so I wanted to squeeze in under the wire, if I may. First of all, I agree that we need some sort of objective test. And by objective, I mean it needs to deal with prejudice. In other words, something along the lines of a Turing test with all of its problems. But I mean, where you can't look, am I dealing with a machine or am I dealing with a creature? You have to just judge it by its outputs. The question then becomes, what sorts of outputs are convincing evidence that the agent is using the sorts of functionality that we are looking for? What Mike has just said.
I have a hypothesis to run by you, and I'll do it by email.
Okay, thank you.
I'll send it to everybody about a way to go with that test.
Please.
Yep.
But what Mike has been saying, and it grows out of conversations I've had with you before, Mike, by which I mean you have extended my thinking along these lines, because I had initially said to you in my first encounters with you, I would only be persuaded that an agent is conscious if it is able to solve novel problems. And I would have to add novel problems which are consequential to its own existence. It's not just a novel problem. It's a novel problem that has that matters to, that it gives a damn about, that has consequences for itself as an agent, because of this the necessarily subjective and so on nature of feeling. What you've just described, which we've talked about before, there's a goal that's written into the algorithm, which is, say, for example, sort the numbers. And then there's a novel problem as to how do I get there? And the agent comes up with a novel solution. This you've persuaded me of. What I'm not persuaded of is that in a situation such as that, it's used feeling in order to get to the novel solution. And so this is how you've how you've forced me to have to think more deeply on matters like this. So in terms of functional criteria, I would like to see evidence that the agent is using this functionality. And I don't think it's something magical. I think this is the crucial thing we need to get our heads around, is what the causal mechanistic powers of feeling are that are not there prior to the emergence of feeling. And I've told you before, Mike, and I'm sorry we don't have time to go more deeply into it now because I really do have to go, but I'll just quickly describe it if for you, Gunnar and Dan, that there's a thing we used with zebrafish, as you guys called, where it's called hedonic place preference behavior, where they hang out on this side of the tank because that's where the food is delivered. Then you deliver cocaine or morphine or amphetamine and even nicotine to the other side of the tank, and they gravitate there and prefer to be there and just dart back for food. And the explanation for that surely is that there is an hedonic, there's a pleasurable it feels good to be on this side of the tank because those substances are not doing it any good. So the feeling is somehow having some causal consequences for the behavior of the fish. And I think something along those lines is what I would like to see from an artificial agent, which that kind of dissociation of the feelings causal power from the causal power of the end goal that is written into the thing, which is survive.
Conflicting feelings. Yes, yes, yes. Yep.
I really look forward to further exchanges with you, chaps. Yeah. And Mike, as always, thank you for introducing me to endlessly interesting people. I don't know where you find them.
Amazing. Yeah, thanks
maybe
so much,
they
Mark.
find you. Thank you, Dan. Thank you, Gunnar. Great to meet you. Cheers. Cheers, guys. Bye-bye.
Bye. Yeah, so we'll obviously do this again, and I got to go in a couple of minutes. I've taken some notes. What I want to start with next time, I want to pick up where he just left off, because Mark focused on the finding novel solutions, but actually my example wasn't even that. It wasn't finding novel solutions to a problem that we gave it. It's finding a new problem that it's dealing with that we never gave it, and that I think is a different story. So we can start on it next time.